Hi everyone. So this is for Algebra 1 and for today 11, 12, 20. So this was our do now today, and I don't know if you guys figured it out as well. So far nobody had figured it out in class, but try to think of a reason why this is equal to 13. You know, what would we do with these numbers? Because it has to do with the numbers to make it equal 13. Okay. And then same thing with the 242. Why is it equal to 10? So look at the patterns, find the patterns. You know, your brain wants to find patterns, right? And then tell me what you think 165 is. So far, nobody in class figured it out. So let's see if you can. We also did Mathia today, and I'm not going to tell you the answer, not until somebody figures it out. I'm not like that. So remember, this is going to be from your Launchpad. You're going to go find a folder, right? It's a folder called Math. Your math folder was put in there from the district, and you're going to, and if you click on it, inside there will be the CL button, but it's like black with white writing inside. It's like flipped, right? It's called Carnegie Learning, and then Mathia, all right? And then once you log into there, you're gonna do the getting started, okay? And that's what I want you guys to do, but not right now because we're doing a video right now. Here, today's lesson was a picture's worth 1,000 words. This is the first lesson in the first unit. All right, and the learning target today is going to be understanding quantities and their relationships with each other. Also, identify the independent and dependent quantities for a scenario. For the warm-up, we had done this graph thing right here, or it's called the warm-up. Normally, I would call it a do now, but we already did the do now. So here we have Emma bought a new video game. The graph shown describes the number of hours Emma spent playing the game over a period of 7 days, right? And so you think to yourself, okay, what is the thing? Remember, we did this like in science, okay, not we, but people have done this in science class, right? Where you make a graph and you learn about independent, dependent variables, right? So independent is always your x-axis, right? And so what is the thing that doesn't ever, it's like the constant thing. Somebody said it doesn't ever change, right? So it's the thing that is constant. I mean, it does change like day 1, day 2, day 3. But so that would be our time. Usually it's time, but it's not always time. Sometimes time is a dependent variable, but usually 95% of the time it's time. Okay, and for us it's the number of days, right? And so that's going to be our independent, because it does not depend on Emma, the number of hours that Emma plays video games, and that's going to tell us what the day is, right? Like, oh, you played 4 hours, oh, that means it must be this day. It doesn't work like that, right? So, and then the number of hours Emma spent playing video games, obviously I can't write all that down, so I'm just said the number of hours. Okay, and then so if you notice right here, this is what it looks like. And what does the highest point of the graph represent? We're like, oh, here's the highest point. And that would mean on the 3rd day, right? We don't know if this is Monday, Tuesday, Wednesday, Thursday, because we don't know when we started, right? But we do know that on the 3rd day, whatever that is, right? Emma played for 4 hours. She must have had a lot of free time, not a lot of asynchronous work. And then on day 7, so the lowest point, which is day 7, right? On day 7, she played nothing. Maybe her mom was like, oh, you've been playing too much video games and look at your grades. No more video games for you. Or maybe it was she had to work and she couldn't go. We don't know. It doesn't matter, right? Because it's not asking why. It's just on day 7, she didn't play any video games. That's what that means. Okay. Here we go. And so here on the next page, we were talking about the independent and dependent. So once you get your books, you can go back, maybe watch this video again, right? And then on here on the side, it has the dependent quantity, which is, you know, one quantity depends on another problem. So it's what it depends on, right? I'm gonna, oh, also on the OneNote, you can click on this, it's the period 2, and then right here, 11, 12, okay? And so from here, this is our dependent quantity, and then the independent one obviously is the one that's independent, okay? And they're calling it the independent quantity, okay? Maybe you guys know it as the independent variable or the dependent variable, okay, but it's the same idea, okay? And so if you didn't read this, you should read this. I like it. So a lot of times when we do things, you know, it does require, like if you're building Legos, right? If you built Legos before, right? There are some things that you need to do there. You can't do the steps in any order, right? You have to do them in order, so that because the previous one depends on the previous, the step after depends on the previous step, right? So they are dependent on each other. Like same thing with Algebra 1 and Algebra 2. You need to take algebra 1 first in order to take algebra 2. You right? They are dependent. So whether you take algebra 2 or not, it depends on whether you took algebra 1 and passed it, right? And if that is not you, or if that's not going to be you, right? So like if you pass this this class, then you can go into the next one, right? So that's going to be that's independent dependent, right? Like you would not make food before you go grocery shopping, right? If you don't have a thing, you can't make a thing, right? So grocery shopping would be first. That's the independent. And what depends on that is you making the food, right? And so there's a little sentence stem here that I kind of put in here. I'm trying to keep the colors the same. So anything that's dependent is going to be this blue, and anything that's independent is going to be this green. So if you plug it in there, it should make sense. So the first one was the number of movie tickets purchased and the total cost, right? So we're going to put in the total cost where the blue is. So the total cost depends on the number of movie tickets purchased. That makes sense, right? Depending on how many you purchase, if you purchase 5, that's gonna the total cost is gonna depend on that, right? So that changes it. All right, and the number of eggs used and the number of cakes baked, right? So the number of eggs used depends on the number of cakes baked. So if we bake more, we're gonna need more eggs, right? I thought of it personally the other way around. The number of cakes baked is gonna depend on the number of eggs. I was gonna say we have, but right? But here it's saying used, not have. So that's why it's not the other way around. Okay, and some of these you can argue the point, right? But we're going to say in general, right? And the same thing with all the rest of these. Okay, you could take a look at them and read them. Okay, and so I know it says circle and underline, but I thought for me colors work a lot. I'm more visual, so colors work a lot better for me instead of circling and underline. But when you get your book, if you want to circle and underline, go for it. That's totally fine. Or this is a good chance to use your highlighter, right? So describe how you can determine. So one person had said this in class, right? So the independent is the thing that doesn't, this stays the same, right? It's constant. I would like to say it's constant, right? It is changing at its own pace. We don't have any control over that, right? So like the movie tickets, like the amount, like the, what we would call the movie ticket prices, we don't have a control over that. It just is set already. And so depending on however many tickets we purchase, right, that's going to determine the total cost, okay? The total cost does not determine the number of tickets we purchase. Although I know you can argue the point, well, what if we only have $50? Okay, we're not talking about that. Okay, we're not doing what ifs. All right, so we're gonna go on to here. So this is 1.1. So this was your homework. All right, we'll go over it though. So determine the, and I'm not always gonna go over the homework, it's just this is part of our learning, so that's why we're gonna go over it. So determine the independent and dependent quantities, right? So if you look right here, so Grayson completes a dive from a cliff of 75 feet above a river. It takes him only 1.5 seconds to hit the water. So 1.5 seconds to hit the water, and then another 0.5 seconds to descend. So they're continuing on from here. Oh, I should probably use a different color. Let me use green. So descending right here. So right here, and then descends another 10 feet, right? And so what is, what are the variables, right? What are the independent quantity and the dependent quantity? And we said independently, and it doesn't like specifically state it here, but anytime you see like seconds or like days or some kind of time reference, you know, probably time is going to be in part of this. So time is the independent quantity because we can't change the time. Time is going to keep on going, right? So it's the time, and what are we measuring it in seconds, okay? And then our dependent is going to be not of the cliff, because a lot of people say the cliff, but it's not the cliff because the cliff doesn't change, right? That's not what we're measuring. We know that it's 75 feet, but what is changing? What is the thing that's changing, right? It's the height of Grayson above the water, or from the water, I guess you could say, right? And so here's Grayson, my beautiful picture, right? And then going down, right? And then going below, right? So height of Grayson from the river, right? In feet. We're measuring, how do we know we're measuring in feet? Because it says right here, it's a 75-foot cliff, right? So that's when we know we're measuring in feet. We like to keep them all the same, all right? So if you don't want to draw the picture, you don't have to draw the picture. And so here we go. And as I said, if you're doing this on a separate sheet of paper, just you don't need to copy this down because you're going to get your book soon. Okay. All right. So here, we'll try a couple more. We won't do the whole thing because this is technically your homework, right? So something's fishy. So Candace is a building manager for Crowley Enterprise office building. Okay. Good information, but irrelevant. One of her responsibilities is cleaning the office building's 200-gallon aquarium. Ooh, numbers. This might be interesting. This might be important. So for cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 10 gallons per minute. Okay. And so we have a tank here, right? A water, and there's some water and it's getting drained out, right? So that water is leaving. How it's leaving, usually you don't have a hole down here. Usually you have like a pipe, right? I used to have an aquarium when I was young, back when I was little, right? So there's the water leaving, and it leaves at 10 gallons per minute. Is that fast? I don't know, but independent, dependent. So if you notice right here, we are talking about, there's a reference to time, and we know we can't change minutes. So so it's going to be time. That's going to be our independent, and it's going to be in minutes, not in seconds like it was before, right? Because the reference is to minutes as opposed to seconds. And then the dependent quantity, okay, what is what depends on the time, right? Well, depending on how much time passed is going to tell us how much water is left, right? So was it the water is left, or is the height of the water? There's a lot of different things. Let me just make sure nope, just water in gallons. We're just going to do, it's going to be the water. I would like to be more specific, but we'll just go waters with gallons. I forget sometimes that this is not algebra 2. So you haven't done all this stuff yet, unless you're taking algebra 1 for the second time, but that is okay. It's a little different. This is a new curriculum. So this can be water in gallons, okay? How much water we have in gallons, whether it is water that's leaving or the height of the water in gallons, or like how much water is in there. But either way, it's the waters in gallons. Okay, and then we're gonna do one more, all right? And so this is gonna be your smartphone, but is it a smart deal? Okay, I don't know. You have your eye on an upgraded smartphone, and maybe you do. However, you currently do not have the money to purchase it. Story of my life, right? Your cousin will provide the funding as long as you pay him back with interest. So it doesn't sound like a very nice cousin. He tells you you only need to pay $1 in interest initially, and then the interest will double each week after that. So that means the next week you're going to have to pay $2 in interest, which is not terrible. So maybe it is a good deal. I don't know. So so you consider this often and wonder, if this really is a good deal? Depends on how much money you have, right? Can you pay him back next week? In which case, yeah, it's a really good deal. You just pay $1 extra, better than the bank. Or you can just, okay, anyways. So what is the independent and the dependent? Well, I noticed that there was a time reference here. Did you notice the time reference? It was like hidden, but yeah, let's talk about each week, right? So we know that we're going to be measuring by time, right? So this is going to be the independent. So time, and we're measuring in weeks. And what is our dependent? What keeps on changing each week? Right, the interest. And how do we measure that interest? In sweat and tears. No, in dollars. So we're just going to go dollars. That is the sign for dollars. So we're just going to go with dollars. I put that in parentheses because that's our unit. Okay. All right. So you're going to be finishing off. Can't wait to hit the slopes. It's magic. Baton twirling, cold weather, and one more, the jelly bean challenge. I don't know if you've ever done this. I've done this for one of my kids' birthday parties and had jelly beans, the mixed kinds. And then I just made sure it wasn't bamboozled jelly beans. And then I said, okay, whoever gets the right amount gets to have the jelly beans. And somebody got really close. Or was it M&Ms? Either way, right? And so that's what you're going to be doing. And we're going to talk more about these in class. All right. So good luck. Do well. Have fun. Actually, maybe should I do it? All right. Well, I would, if you have not stopped, right? Take a look at it. Do them. Stop now. Do them, and then press play. All right. We'll do homework together today, I guess. I was gonna stop, but I guess I'll be nice and do the homework with you guys. Okay, so Andrew loves skiing. He just hates ski lift. To make matters worse, the ski lift has been acting up today. If you've ever been on a ski lift, it's actually kind of high. I've been on there maybe a few times, not a lot. And then again, or if you've gone snow tubing, right? It's a similar kind of thing, except you have a snow tube in your hand, which is kind of scary. So Andrew is using the GPS on his phone to track the ski lift's progress as it travels up the mountain, right? And it moves at a steady rate of 400 feet per minute until it stops suddenly. Andrew calls his friend to tell them that he is stuck. Sad days. And then they talk on the phone for 10 minutes until finally the ski lift begins to move again. All right, so what is the thing that is the independent quantity? Did you hear it? Did you see it? Did you notice? Right? We're talking about minutes here. I noticed there was minutes here. There was 10 minutes here, right? Because notice that's when it's paused, right? So think about what that would do to a graph if we were to actually graph the thing, right? And so we're going to go time, and what is it in minutes? And then what about the dependent, right? He's using his GPS, right, to track what? Distance, right? So this is going to be distance, how far he has traveled, distance. And then this is going to be in miles, feet. And you notice, oh, feet are mentioned here, not your feet. Distance, feet, right? So there's distance, feet. Happy days. Okay, next one, magic. It's magic. The amazing, oh shoot, Aloysius is practicing one of his tricks. As part of his trick, he cuts a rope into many pieces and then magically puts the pieces of rope back together again. I've seen this kind of trick. I don't know how they do it. He begins the trick with a 20-foot rope, then cuts it in half. I don't even know how you're gonna like try and get half of that. Anyways, and then cuts it in half. Then he takes one of the halves and cuts that piece in half, and then keeps on cutting him half, right? And so until he's left with a piece so small he can no longer cut it, okay? And so independent quantity, I didn't see any mention of time here, so there's no time, all right? Because it's not saying how long does it take, right? It's not any of that. So, but I do notice the thing that is happening that is always consistent is the number of cuts, right? So this is gonna be the number of cuts. And then what's the dependent? So depending on the number of cuts, that's going to determine how long or how short the piece is, right? So length of piece, rope, length of rope. And what do we measure that in? And it looks like in feet, foot, you know what I mean? Okay, so the length of the rope piece in feet. So if you wrote something to that effect, you're good. Good job. All right, so let's talk about baton twirling. I am not good at this. Are you good at this? It would be cool to see this. So Jill is a drum major, but I was a drum major, go band, for Altadena High School. Altadena? Anyways, a high school marching band. For the finale of the halftime performance, Jill tosses up her baton in the air so that it reaches a maximum height of 22 feet, and this gives her 2 seconds to twirl around twice and catch a baton when it comes back down. That's definitely not me. So what is the independent and dependent, right? I noticed time, right? So there's time here that's going on. So time in what? Time in seconds, right? Because it says seconds. And then also, so then what's the dependent? So depending on the time, that's gonna determine the height of that baton, right? So we're gonna say height of baton. And what is that measured in? Feet. A lot of things are measured in feet. If we were anywhere else in the world, it would be in meters or centimeters, right? But we have feet. Well, everybody has feet. All right, so here, cold weather. The number of guests in a ski resort on any given day is related to the day's high temperature, okay? If a high temperature is negative 20 degrees, that doesn't make it, so probably just 20 degrees or below. Oh, let me check in my book. Is it negative? Oh, it is negative 20 degrees. I don't know why it looks so weird there. So negative 20 degrees or below, no one comes to the resort. Yeah, because it's freezing. As the temperatures increase, so does the number of guests. Do you see the dependent and independent variable here? So once the temperature reaches 0 and increases through the single digits, the number of guests soar. If the temperature is 10 degrees Fahrenheit or higher, the key resort is at full capacity at 400 guests. Okay, so what, did you see what I saw? So what is the independent quantity? What can we really not change, right? That's gonna be the temperature, right? You can't, nobody can do that. They can try and predict it, but we can't change that, right? Unless it's in your room and you have a thermostat. So temperature, and that's going to be degrees in Fahrenheit. Or you can write out degrees in Fahrenheit. I'm just going to do that. All right, and then what is the dependent? What depends on the temperature, right? For me, I noticed it right here. So as the temperature increases, so does the number of guests. Did you notice that? So it's going to be, the dependent quantity is going to be increases, so this is going to be the number of guests. And we're not, there's no label for this because this is just people, right? This is just guess. It already has the information. So you're good there. Good job. And we're now at the last one, guys. Yay, we're almost done with our homework. All right, so Mr. Wright judges at the annual Jelly Bean Challenge at the summer fair. Every year he encourages the citizens of his town, probably it's a very small town, that's why it's called a town, to guess the number of jelly beans in a jar. He records all the possible guesses and the number of jelly beans that each guess was off by. So he's subtracting. So if they were too high by 5, so that how much they were off by was like 5, right? So what's the independent quantity? The possible number of guesses. So possible guesses, right? And then what is the dependent? What does that depend? That's right here, the number of jelly beans each guess was off by. Because depending on what that guess was, that's going to determine how much it was off by, right? So we're going to say, I'm just going to copy that down. Number of jelly beans that each guess was off. Was off by. I always say off by, but it's off by. All right. So that would be the dependent quantity. Okay. So, and now we're done. Now you're done with your homework. Good job. Yay. Don't forget you do your math. Yeah. All right. I'll talk to you later. Bye.